Hello, and welcome to the fourth video in our Vibration Diagnostics for Beginners series. In this video, I will explain simply how to create a factory measurement journey known as a route for your predictive maintenance and which are the main values for vibration measurement. So let's begin with these terms: frequency, amplitude, and period. Frequency is, in vibration measurement, the number of occurrences of a repeating event per second, and the unit is Hertz. Period is the duration of time of one cycle in a repeating event, so the period is the reciprocal of the frequency. See in this picture the difference between frequency and period. Amplitude is the maximum extent of the repeating event. There are various definitions of amplitude, which are all functions of the magnitude of the difference between the variable's extreme values. The RMS value for sinusoidal functions is 1 divided by the square root of 2. It equals approximately 0.7 of the zero peak amplitude. The RMS value is the most commonly used value. The speed value for rotating machines and its parts is measured in revolutions per minute, RPM. Amplitude can be measured or displayed in 3 types of physical quantities, as you know from previous videos: displacement, velocity, and acceleration. Displacement means the distance between the stable and exceed position. It tells us how far the measured point is moving. The units are millimeters, micrometers, or thousandths of an inch, or mils if you prefer. Velocity is the rate of change of a distance, displacement, with respect to time. It tells us how fast a measured point is moving. Units are millimeters per second, or inches per second. The highest speed is in the middle of the movement. Acceleration is the rate of change of a velocity with respect to time. It tells us how fast the velocity of the measured point is changing. Units are g, or meters per second squared. The biggest acceleration is at the points where the movement reverses direction. We have 2 main ways of displaying the vibration signal. For us, this means frequency and amplitude. The first one is the time waveform, or time domain view. For the displacement value, it is a pure view of the sensor's total movement in time. For other physical quantities, it is their pure record of change over time. The time waveform shows a short time sample of vibration. The second type is the spectrum or frequency domain. It is the view of each frequency component of the sensor's total movement. It allows us to see all amplitudes of frequencies the time waveform is made of separately. According to Fourier analysis, any physical signal can be decomposed into a number of discrete frequencies, or a spectrum of frequencies over a continuous range. You can imagine a spectrum as an equalizer, which is visualizing the amplitude of the frequencies the music is made of. For better understanding, imagine a foundation or frame with 2 motors mounted on it. The motors have different unbalance and different speed values. If you put the vibration sensor on the foundation, you can measure the overall value like this: 6.3 millimeters per second. But you are not able to distinguish which motor is causing most of the measured vibration. Then you can look at the signal in time wave form. You will see this. The signal is composed from 2 separate vibrations from each motor. You are probably not able to identify the source of the vibration either. Finally, you choose the spectrum view on a measured signal. So the signal will be decomposed into discrete frequencies and shown to you from this view. And from this point of view, you can easily say that the motor with the speed of 40 Hz is causing the problem. How to create a factory measurement journey. Factory measurement journey? Let's give it a different name. The route. Why? For the beginning of our predictive maintenance program, we will use 2 measurement types per measurement point, as agreed. See item 1 on the picture from our DDS software. These are velocity in millimeters per second and acceleration in g measurements. These 2 data cells lay under the measurement point, item 2 on the picture. The measurement point is the place on the machine where we will be taking the measurement. There will be more measurement points on each machine. For example, on each bearing housing of the machinery component, plus 1 on the axial direction on the machinery set. Another is item 3, which is our machine or machinery set. We can create more machines, and they can lay below a section or division of your company. In our example, it is Department 1, which is represented by number 4 on the picture. I guess you will agree that this sketch looks like a tree with branches, and that's what we will call it, the root tree. We will create our root tree in the DDS software, and it will basically guide us to which department we should go, to which machine, and where to place the sensor to take our measurements. We have created a lot of DDS tutorial videos which describe, for example, how to create the root tree, how to work with graphs, how to set up vibration limits, and many more. Subscribe to the ADASH YouTube channel and learn very quickly how to use our products and how to get as much as you can from your predictive maintenance program. Now you have created your root tree and you regularly measure your machines, for example 2 times per month, it is time to track the trend of vibrations on individual measuring points and see their development in time. Stable trend. Is your trend of velocity and acceleration measurement stable, like in the picture? A stable trend with acceptable values means that your machine or bearing is running under stable conditions. Then you should not be worried, and this machine can be operated without any restrictions. Attention! Even if the trend is stable, there can be cases when the machine will break down without any warning. This can happen, for example, if the machine runs with some manufacturing defect. It does not happen very often, but it happens. Unstable trend, rising trend. Is your trend of velocity or acceleration measurement rising, like in the picture? Is it the velocity measurement? Then, as we learned, it will be a mechanical fault related to the speed of the machine, such as unbalance, misalignment, or looseness. You should measure the machine more frequently and look for a deeper analysis of the machine to find out what the problem is. Is it the acceleration measurement? This higher frequency measurement is most often related to bearings. Grease the bearing. Measure it more frequently, and if the value is still rising, you should plan to change the bearing. Our expert system Facet would help you uncover the cause of machine health degradation. You can also simply trend the Facet values and see the trend of misalignment, unbalance, looseness and bearing condition on your machines. Predictive maintenance, and particularly vibration measurement, is one of the best and most proven methods for knowing the actual condition of your machinery. It allows you to track its condition over time and enables you to plan and schedule potential repairs of the machine. However, it can never work 100%, and some sudden machinery breakdowns can still occur. To keep your machinery running, try to do more than just regularly measure your vibrations. Be smart. Try to get to know your machine. Keep your machinery clean. Observe the machine. Look for potential oil leaks, air leaks, etc. Look for potential foundation cracks, structure cracks, loose bolts. Listen to the machine. Especially look for sudden noise change. Share information about the machine. Use the buddy system. In other words, if you discover some unusual behaviour in any machine, tell your workmates. You can not only avoid an unexpected breakdown, but you could also save your colleague's life. So you can see that the basics of vibration analysis are not that difficult, and a lack of knowledge or practice does not prevent you from starting with predictive maintenance.